simplify the radical, we're going to pull out groups of the root. So since there's not a root there, I can tell you that it's a second root. So anytime it's not present, it's a second root. So I'm going to break this down into its primes. I'm going to start with 24. 24, I do what's called cake division. I divide its primes, so I'm going to start with 2. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. Now, I can no longer use 2, but my next prime number is 3. So I'm going to divide 3, and 3 goes into 3 one time. And the reason why I call this cake division is I stop when there's a candle at the top. So I'm going to rewrite this inside. This is the second root of 2 times 2 times 2 times 3. And if I multiply those together, I get 24. And I have 3 x's. So now what I'm going to do is I'm going to group them into groups of 2. There's a group of 2. There's a group of 2. So on the outside, I have a pair of 2's, and I have a pair of x's. On the inside, I have 2 times 3, which is 6, and 1 x. And there's my final answer. Let's try another one. This time I have the third root, so I'm going to break 24 down quickly the same way we did on the last screen. So that's 12, 2 goes into it 6, 2 goes into it 3, 3 goes into it 1, and I have a candle at the top. So if I break this down, it's the third root of 2 times 2 times 2 times 3, and 3 x's. Now we're going to circle groups of 3's. So there's a group of 3, and there's a group of 3. So I have a group of 2's that come out. I have a group of x's that come out. Left over inside, I have a 3, but it's very important to put the third root. So now the exact same problem was broken down 2 different ways depending on what the root is.